This is Lesson 5-7 on matrix multiplication, Part 1. So far we've been talking about matrices a little bit. We've talked about how we can use them to help solve systems of equations. We've talked about how to add and subtract matrices. So we're going to start talking about multiplying matrices. Unlike addition and subtraction and multiplying by a scalar, all of which were relatively easy things to do, multiplying two matrices is actually significantly more difficult. Not impossible, but certainly more difficult. In order to talk about multiplying matrices, we need to have a pretty solid grasp on how we look at the size of a matrix. So when we look at the size of a matrix, we need to look at the number of rows and the number of columns that that matrix has. So for example, if we talk about a 4 by 6 matrix, what that means is that this matrix has 4 rows and 6 columns. So the way that we look at the size of a matrix, count down and to the right. So start at the top left of the matrix, count down, that's going to give you the number of rows, and then from there count to the right. That's going to give you the number of columns. Now understanding how to talk about the size of a matrix is very important when we're talking about multiplying two matrices. Now the somewhat convoluted way that we multiply matrices, and it is convoluted, but it actually it makes sense. It's actually somewhat helpful that we do it the way that we do, but at first glance it does look complicated. In order to multiply two matrices, we need to have the number of columns in the first matrix equal to the number of rows in the second matrix. So in other words, if we take the size of the two matrices and kind of place them side by side, the size of the first matrix and then the size of the second matrix, we would want the two inner numbers. So again, the number of columns for the first matrix and the number of rows for the second matrix. We want those to be the same. If they are not the same, then taking the product is very easy. It just simply doesn't exist. Now, if the product does exist, so if those two inner numbers are the same, the size of the product is going to be the outer two numbers. So in other words, the number of rows of the first matrix and the number of columns of the second matrix. So when we're taking a product, if the inner two numbers match, the size of the product is going to be the outer two numbers. So for example, if we had a 3 by 2 matrix and a 2 by 4 matrix, the resulting product would be a 3 by 4 matrix. So here we see I've written the two sizes side by side. Notice that the two inner numbers match. They are both 2's, so the size of the product is going to be the two outer numbers, 3 by 4. Now if we switched it the other way around and said we wanted to take a 2 by 4 matrix and multiply it by a 3 by 2 matrix, we couldn't do that because the inner two numbers do not match, so there would be no product. So this is a simple example bringing to light a pretty important fact about matrix multiplication, and that is matrix multiplication is not necessarily commutative. So in other words, that means that the order does matter. So when we're dealing with scalars, multiplication is commutative. 4 times 5 is the same as 5 times 4. Here though, that is not the same. We see an example here where a 3 by 2 matrix by a 2 multiplied by a 2 by 4 matrix, that exists. That will give us a 3 by 4 matrix back. However, change the order so that we have a 2 by 4 matrix times a 3 by 2 matrix, that no longer exists. So the drill problems from this section are very quick and easy. You're going to be given the size of matrix A, the size of matrix B, and you're asked to tell the size of matrix AB and matrix BA. So AB, that's going to be the product of A times B. BA will be the product of B times A. So if the product exists, tell the size of it. If it does not exist, just state that it does not exist. All right, let's look at two quick and easy examples. So we want to find the size of AB and BA if they exist, given the size of A is 4 by 5 and B is 5 by 3. So for AB, we're going to first write the size of A, so 4 by 5, and then the size of B, 5 by 3. So notice here, our two inner sizes are the same, so the product is going to be size 4 by 3. So AB is a 4 by 3 matrix. For BA, same idea, opposite order. So we're going to put the size of B first, and then the size of A. So notice this time the inner two numbers are not the same. So that means that BA doesn't exist. So we'll usually use DNE as shorthand for does not exist. That's pretty common throughout math classes. So there we go. AB is a 4x3 matrix. BA simply doesn't exist. Alright, second verse, same as the first. So AB and BA, here we're given the sizes of our two matrices. So AB, we put the size of A first, so 3x2, and then B, 2x3. Alright, inner pair numbers are the same, so AB is going to be the outer pair. So AB is going to be a 3x3 matrix. For BA, same idea, opposite order. 2x3, 3x2, inner pair numbers are the same, so the outer pair gives me my size. So BA is going to be a 2x2 matrix. And that's it. That's all there is to this. So this is a very simple, very quick idea, but the underlying concept is very important.